Hi, today we're going to start chapter 7, and this is section 7.1 on the properties of exponent, the multiplication properties of exponents. This whole chapter is going to be about exponents and several different properties, as we'll see. But today we're going to start with this one, on the multiplication properties of exponents. One little definition that we're going to take a look at before we go here, get started, is this thing called a monomial. And you guys know that mono means one, and a monomial is an expression that just has one term in it. Okay? But one special thing, it cannot have a variable in the denominator. It can have numbers in the bottom, but it cannot have letters in the denominator. Okay? But a monomial there is an expression that only has one term. Okay, we're going to take a look at a couple here. It's going to determine whether each expression is a monomial, write yes or no, and explain your reasonings. And you can see your answers there. Letter A, they're just the number 10, just a regular number. One term, yep, it's a monomial. As you can see in letter B here, this guy has two terms. Okay, it has more than one, so it is not a monomial. Okay, it can have exponents in it, and it can just be a single variable. Okay, very good. Okay, which one of these are monomials? We take a second here and go through these one by one. 1A, this one would not be a monomial because it has two terms. That actually is what this thing is called, a binomial. Okay, 1B over here to the side. This one is just one giant term. It has variables, exponents, constants, but there's just one big term there. It's not separated by any addition or subtraction. Okay, 1C, this is also a yes. Now there's a fraction there, but if you notice in the bottom, it's just a number and not a variable. And we can have numbers in the bottom. And this guy over here, this guy is a no-go because it has an n on the bottom. It has a variable on the bottom. Okay, so kind of the first thing they're going to have us do is just determine if it's a monomial or not. Okay. Okay. All right. Now we're going to get into kind of the nitty-gritty of things here. We're going to look at the first property of exponents. There are two of them that we're going to look at today. And here's number one. Okay. If I had x squared times x cubed, and I wanted to know what that product is. Okay. Well, x squared we know is x times x. How many x's is x cubed? It's 3 of them. And if they're being multiplied together, how many x's do we have altogether? There's 5 of them. And another way to write 5 x's would be to write that as x to the 5th power. Okay? And some of you already see a little pattern between these and this. Okay, but before we get to it, let's try one more of these. Okay, let's scooch this up here a second. Okay, how about this? What if I had x to the 5th times x to the 7th? Okay, and I want to multiply those two things together. Well, I can list them all out here. X to the 5th has 5 x's. X to the 2nd is 2 x's. And how many x's do we have altogether? If you add them up real quick, there's x to the 7th power. Okay. And if I go along here, and again, I think many of you see the pattern. What is the little rule with this first property of exponents? We're going to add them together. We're going to add the exponents. That's what I have here in my next slide. Yep, that's what we're going to do. Okay, so let me try one more here. Suppose I had this one. How about 3x to the 4th times 2x squared? Okay, what if I have two monomials being multiplied together? Okay, well, I can multiply big numbers with big numbers. Okay, 3 times 2 is 6. And then again, if I look at my exponents, I have 4 of them right there, 2 of them right there, for a total of 6 altogether. So I get 6x to the 6th. Okay. So once again, we're adding those exponents. Okay. Let me try one other one here. What if I had negative 3x times 4x to the 7th? Okay. Again, if I multiply big numbers with big numbers, negative 3 times negative 4 is negative 12. And I see an x to the 7th, but I don't see an exponent right there. If it's just a plain old letter, variable, and there's no exponent on it, you're right, it's x to the 1st power. And if I add them together, 1 plus 7, I get x to the 8th power. Okay? But once again, we're adding the exponents together. And if it doesn't have one on there, it's just the first power. Okay? Okay. All right, let's take a look at the second property of exponents. We'll go back and do some more practice ones here shortly. But the second property of exponents is, what if I had this? What if I had x to the third and I raised it to the second power? Okay. Well, this exponent out here tells me that I'm going to be multiplying something together 2 times. That's what squared means. Okay. And what am I going to multiply together 2 times is whatever's on the inside of the parentheses. X cubed times x cubed. Okay. Well, think about this and think about what we talked about just a minute ago. When I multiply these things together, this is 3x's. This is 3x's. If I add them all together, I get x to the 6th power. Okay? And some of you guys probably can see this. There's a relationship between those exponents and x to the 6th. Okay? Let's try one more of these real quick, and we'll see if we can come up with another little pattern. Okay? How about this guy? X to the 4th, and I'm going to cube it. Okay? Well, this tells me I'm going to have something multiplied together 3 times. That's what cube means. And what's on the inside of the parentheses that's going to get multiplied together 3 times? X to the 4th, x to the 4th, x to the 4th. And without writing out 4x's and 4x's and 4x's, we can use that little rule that we talked about here just a minute ago. And if I add those exponents together, how many x's will we have all together? 4 plus 4 plus 4. We're going to have x to the 12th power. Okay? And many of you, like I said, is there a relationship between a power to a power and the exponent there? And just as you think it is, we're going to multiply the exponents together. That's kind of what I have right here. Okay? And this kind of summarizes, let me go back down a second, kind of summarizes that little rule that we just talked about here, property number 2. Okay? You can see, if I multiply them together in a different color, 3 times 5 is the 15th power. 7 times 6 is the 42nd power. Okay? This bottom one, I guess I didn't quite get to yet. I'm going to come back to that in a second. I'm going to go back here for a second. And the bottom one I had down there is, what if I had this? 2x cubed y squared, and I raised it to the 3rd power. What if I had more stuff on the inside of the parentheses? Okay, well, this little exponent out here is going to multiply that exponent, and that exponent. Okay, it multiplies to everything on the inside of the parentheses. Okay, so I'm going to end up with 2 to the 3rd, x to the 3 times 3 or 9th power, and y to the 6th power. Okay? And one thing I'm going to try to emphasize here, whenever we have a number that's raised to a power, let's go ahead and multiply that out. 2 to the 3rd power, whether you use your calculator, maybe you know it by hand, but 2 to the 3rd power is 8. X to the 9th, y to the 6th. Okay, but if we can kind of keep that as a general rule of thumb, if we have, anytime we have a power to a power, let's go ahead and multiply it out. Okay? But this is really just an extension of the one that we talked about a minute ago. When we have a number, just a bunch of stuff on the inside of the parentheses, we take that exponent and we multiply it or distribute it to everything. Okay? And if I go ahead here, that's what this bottom one is saying right down here. So you can kind of see how this 5 multiplied to everything. It ends up with negative 2 to the 5th power is negative 32, x to the 5th, and y to the 15th. Okay? So it's just kind of an extension of the first one. Okay? Here's a little word problem that we're going to try. Or actually, they have it for us here. Okay? They want us to write an expression for the area of that circle. Okay? The area of a circle is pi r squared. Okay, where r stands for the radius of the circle, right over here, which is 2xy squared. Okay, they substituted that in right here. Okay, distributed or multiplied that exponent through, got 2 to the 2nd power, which is 4. X squared, 2 times 2 is y to the 4th, and then we wrote the pi at the end. Okay, and ended up with 4x squared y squared pi. Okay? When you guys get to geometry, you'll see some of these equations that will involve these properties, the multiplication properties of exponents. Okay? Okay? All right. Lastly, here we're just going to practice a couple of these examples with some of the different properties. Okay? And here's the first one that I'm going to take a look at. Okay? What if I had 2n cubed times 5n squared? And notice those exponents. Are they inside the parentheses or outside the parentheses? They are inside the parentheses. Okay, so I'm going to multiply my big numbers with big numbers. 2 times 5 gives me 10. And n squared and n cubed, we're going to add those together to get n to the 5th power. Okay, again, when the parentheses are inside, we add them together. Okay, we're trying another one here. What if I had more than, well, one more time here. How about this one? 3xy cubed and 2x cubed y to the 4th. What if I had just a little bit more stuff on the inside of those parentheses? But notice again, everything is on the inside. Well, if I multiply big numbers with big numbers, okay, this is x to the 1st. I have 1x and 3 x's. I end up with 4. And 3 plus 4 is 7 y's. Okay, that's kind of an example of the first property that we looked at. Okay. Okay, let's try this one. Here's number 3. Just a couple more. Okay, how about this? 2a cubed b to the 5th to the 3rd. Now, if you look carefully here, there's one on the outside of parentheses. This exponent out here. When it's on the outside, I think it's a really, really good idea to draw those arrows so you can see how it gets distributed, just like when you did the normal distributive property. We end up with 2 to the 3rd, because remember, this is a 1, and 1 times 3 is 3. A to the 3 times 3 is going to be a to the 9th. And then 5 times 3 is 15. And like I said a minute ago, anytime we have a number to a power, let's multiply it out. Whether you use your calculator or 2 times 2 times 2 is 8. A to the 9th, b to the 15th. Okay, there's an example of that second property. Okay, get another one here. Oops, move up here a second. Here's number 4. Okay, how about this guy? 3a squared cubed squared. Okay, holy mackerel, look at that big thing. Okay, now normally when you guys see a bunch of parentheses like this, you oftentimes think of, with PEMDAS, you start in the innermost parentheses first. But with exponents, we start on the very outside. So I'm going to start out here, oops, and I'm going to go 3 times 2. That's going to give me 6. So now we have all of that stuff raised to the 6th power. Okay. And now I'm going to take that 6 and I'm going to distribute it through to everything on the inside right there. Okay. And I'm going to end up with 3 to the 6th power. And I'm going to multiply again a to the 12th power. Okay. And if I use my calculator and I do 3 raised to the 6th power, if you took a second to do that, you would get 729 a to the 12th. Okay? But when we see multiple parentheses, where things are raised to a power, we start on the outside. I think it's easiest if you start on the outside and you work your way into the middle. Okay? Okay. All right, very nice. Okay. Another thing that we haven't really talked about here are fractions. Okay. Here's number 5. How do I do something like this? 2x squared over 3y to the 4th, and I square it. Okay. The way we do fractions, we do them the exact same way. We're just going to treat the numerator and denominator separately. this little exponent out here, it gets distributed to everything in the numerator. Okay, so I could do 2 to the second, which is 4. 2 times 2x to the fourth. Okay, but that exponent of 2 here, it also goes to everything in the denominator. So it goes to the top and the bottom. So on the bottom down here, I get 3 to the second, which is 9, and 2 times 4y to the 8th. So fractions aren't anything to be scared about with exponents. Okay, we just do it separately. It goes to the top and the bottom. Okay. Okay. All right, I got 3 last ones I want to do. We're going to kind of combine the whole shooting match here together. Try these last 3 problems. Here's number 6. Oops. Okay, number 6. Okay, we're going to try 5x squared y squared times 2 xy cubed cubed. Ha. Okay, so what's the easiest, the easiest way to tackle this? I would say do each one separately. Okay, so kind of treat that time sign as a little divider. And let's do the one on the left. I'm going to distribute. 5, well, maybe I'll write it here. 5 to the second, x to the fourth, y squared. And 5 to the second is 25. Now be careful, it's not 10. It's 5 times 5 2 times, which is 25. X to the fourth, y to the second. Okay. Then I'm going to take a look at the one on the right. I'm going to distribute this one through. I'm going to get 2 to the third. Remember, that's a 1. X to the third. And 3 times 3 is 9. And if I evaluate 2 to the third, we've seen it a couple times now, that's going to be 8. X to the third, y to the ninth. Okay, so kind of starting these, break them apart into separate ones. I always look for an exponent on the outside, and if there's one, we distribute it through. Now the parentheses are gone, and I just have 2 little expressions left over. And again, I can multiply big numbers with big numbers. 25 times 8. Think about this. How much is 8 quarters? 8 times 25 is going to be 200. X's, I have 4 X's here and 3 X's there for a total of 7 X's. We're adding now again. And then I have 2 Y's and 9 Y's. That's a total of 11 Y's. And there we have it. Okay. So again, when the expressions get to be a little bit bigger, just take one chunk at a time. Okay, there it is. Okay, all right. Here's my second to last one, number 7. Okay, looks something like this. My cheat sheet here. Negative 4a squared b squared squared. Negative 2, oops, sorry. Negative 2 a to the 5th, b to the 6th, cubed. Okay, now this one, we haven't seen one of these yet. What about if there's negative numbers in there? Well, we do the exact same thing. Right? I'm going to kind of break this apart into 2 separate ones. I'm going to take my exponent on the outside and distribute it to everything on the inside. Okay, now I'm going to kind of go backwards here. I think we can get b to the fourth, a to the fourth, but the question is out here. It's not 8. Now remember, this is negative 4 squared. And that negative sign is in the parentheses, so technically it's negative 4 squared. Okay? And negative 4 squared, if you think about it, it's negative 4 times negative 4 2 times, which is a positive 16. Whenever you square something, we're going to get a positive number. A to the fourth, b to the fourth. Okay, there's the left-hand side. If I do the same thing over here on the right-hand side, okay, I'm going to get negative 2 to the third, a to the 15th, I'm going to multiply again, and b to the 18th. Okay, and this is the tricky part right here. Negative 2 to the third power. Now you can use your calculator, but just be really, really careful. Always put that in parentheses. Or you can simply write it out also. Negative 2 times negative 2 is positive 4, and 4 times negative 2 is negative 8. A to the 15th, B to the 18th. Okay, but the negatives are the ones that can be a little bit tricky. Okay. Lastly here, I'm going to multiply these guys together. If I do big numbers with big numbers, if I use my calculator here, 16 times negative 8 is negative 128. And if I combine my A's, oops, A to the 4th and A to the 15th is going to give me, I add them, I get A to the 19th. And if I combine my B's, B to the 4th and B to the 18th, I add them together, I get B to the 22nd. Okay? And that would be my grand finale answer right there. Okay, so again, the problem starting at the top here looks kind of scary, but it's not too bad if you break it apart into small little pieces. Okay? All right, I got one last one here that I'm going to do with you. Number 8. Okay, it looks like this. 4/5 x squared y cubed. And I'm going to raise that to the 3rd power. Okay? Again, it has a fraction in there. Okay, just like we've been talking about, when there's one on the outside of the parenthesis, it distributes. That 3, the 3rd power, goes on the 4, and it also goes on the 5 down there at the bottom. Okay, so if I can do this, it'd be 4 to the 3rd power over 5 to the 3rd power. Because remember, these start out having a 1 on them. Okay, I'm going to multiply my x's, x to the 6th, y to the 9th. Okay, and last but not least, if I just simplify my fraction, 4 to the 3rd power is 64, if you did 4 times 4 times 4. 5 to the 3rd power is 125, and then x to the 6th, y to the 9th. Okay, you can certainly leave it like that. If you remember, technically these things are over 1, aren't they? So if I wanted to, I could write everything in the numerator and 125 in the denominator. But you can leave the fraction as a separate thing out front, or you can certainly combine it and make it one fraction altogether. Okay? All right. Last but not least, I want you to try 2 problems on your own here. Okay? I'm going to put these up here, then, and then once I get them up there, I'm going to have you push pause on the video here, try them, and then unpause, and I'll work through them together with you. Okay? So here's the first one I'd like you to try on your own. Okay? Looks something like this. Negative 5, x to the 3rd, y to the 4th, cubed. Okay. And number 2 is going to look like this. Negative 3, x squared y. I'm going to square it, and I'm going to cube that. Okay. So go ahead and push pause. Take as much time as you need, and when you're ready, unpause, and we'll come back and do these together. Okay, welcome back. Okay, let's give this a shot. Okay, if I do this at the top here, I'm going to take my 3 and distribute it through. And notice there's a negative sign, and it's inside parentheses, so it's going to stay inside parentheses. So it's a negative 5 to the 3rd power, x to the 9th, y to the 12th. If I multiply them, that's going to be negative 125, x to the 9th, y to the 12th. There's the first one. Okay. Now, if you made a mistake on one, I'm hoping you can see how and where it went, or where you made your mistake. Okay, but there it is. And one last one here. Okay, oh man, look at this big thing. I have parentheses on the inside, bigger parentheses, and then some way on the outside. Like I mentioned earlier, the way we're going to do these is we'll work our way from the outside in. 3 times 2, I'm going to multiply those together, and it's going to get a 6. So all that stuff in the middle here is going to be, this stuff is going to be raised to the 6th power. So that 6 is going to go on the 3, it's going to go on the x, and it's going to go on the y. Negative 3 to the 6. I'm going to multiply 2 times 6 and get 12. And then there's a little 1 on there. And 1 times 6 is 6. Okay. And last but not least, I'm going to grab my calculator, and I'm going to do negative 3 raised to the 6th power. Oops. And that's going to be 729. X to the 12th, y to the 6th for my grand finale answer. Okay. So that's our first property of exponents. It's the multiplication property of exponents. We'll look at some others in the future here. And if you have questions in the Google Classroom, there are a couple other videos that you can certainly go take a look at if you want to or need a little extra help with it. All right, see you back.